Today we're talking about similar triangles and indirect measurement. Okay, triangles that have the same shape but not necessarily the same size are similar. In similar triangles, the measures of corresponding angles are equal, and the measures of corresponding sides are proportional. When some measures of the sides of similar triangles are unknown, proportions can be used to find the missing measures. Example. It says if triangle DEF, and this is the symbol we use for similar. It's just one squiggly line. Is similar to triangle ABC, find the value of x. Now the order is important. In other words, this vertex D matches up with vertex A. Vertex E matches up with vertex B, and F matches up with C. The order is important. Now, this is for triangle DEF. We're going to make a fraction of the sides of DEF, that triangle. And over here, we're going to make a fraction of this triangle. Okay, so looking at DEF, here's D, E, and F. This is X right there. I'm going to put this up on top. It's always best to start with X in the upper left-hand corner. Now, where does that match on the triangle ABC? Where does this side DE match? Well, DE should match up with AB. And if I look at AB, that is 20. So that's our top number right there. Now we're going to compare it to another one, another side on this triangle. Let's go to triangle DEF. We know what X is, and we know this side right here. EF. That's 12. So I'm going to put that with this triangle. We know an X and a 12 for triangle DEF. For this triangle, we know 20. That matches up with the X. Now, what one matches up with the number 12 on this triangle? We have EF. That would match up with BC. See that? EF matches up with BC. I look at BC. It's 30. So we're saying this triangle, this ratio of X over 12 should equal 20 over 30. Just kind of going back to the triangles again. X over 12, okay, this side over this one is equal to this side, AB, over this one. See how they match up? They're similar. So if they're similar, we can say that they are equal to each other. Okay, now we solve the proportion for X. Let's see, if I could multiply by 12 over here and multiply by 12 over there. See that? And that's gone. And X equals 12 times 20. 20 times 12 over 30. Okay, let's do some reducing here. First of all, 10 goes into 20 and 30. 10 goes in here 2 times. 10 goes in there 3 times. 3 will go into 12. 3 goes into 12 4 times. 3 goes in there once. 3 goes in there 4 times. So what am I left with? 2 times 4. 2 times 4 is 8. So our answer is 8. Actually, our answer is 8 feet. Why do I say that? Because we want to know how long this is. It's in feet, so it's 12 feet. I'm sorry, 8 feet. What am I saying? 12 feet. 8 feet. And there's the answer right there. The answer is 8 feet. My bad. All right, next. Let's go on to the next one. Write a proportion to find each missing measure of X, then find the value of X. Okay, so we have our X, and we only have one other number up for this triangle. We have X and we have 24. X over 24. On the other triangle, which one matches up with the X? Well, that would be the 6. The 6 matches up with it. So that goes on top just like the X is. And the other number is 8. The 24 matches up with the 8. Okay, now we just solve for X. So what we can do is, I'm going to multiply by 24. I multiply by 24. All right, x is by itself. Let's see, what can we do here? I'm just going to put a bar across here. Extend that. Oh, notice that 8 does go into 24. 8 goes in here. 8 goes into 8 once. 8 goes into 24 3 times. So now I just have 6 times 3. That's 18. Now is it 18 what? Feet, yard, what is it? It's 18 inches. That's our answer. So we just solved for this one right here. X is 18 inches. And we use this by similar triangles, making a proportion. Count number 2. Here's X right here. All right, and that's going to match up with what, the 12 or the 5? It matches up with the 5. So I'm going to put that on top over here. And then for this triangle, that's 24. So x over 24 is equal to 5 over 12. Okay, because this is one triangle, this is the other triangle. Now we can reduce. Let's see, I'll multiply by 24. Multiply by 24, just extend it out. Okay, so that's gone. You have x by itself. 12 goes into 24. 12 goes in there once. 12 goes in there twice. Now I just have 5 times 2. 5 times 2 is 10. And the units are kilometers. km, kilometers. And there's our answer. 10 kilometers. So you just found the distance of that side of a triangle by using proportions. Okay, number 3. Here's our x right there. So we'll put that on top. Now, let's see. What does that match up with over here? The 5 or the 10? Well, it matches up with the 10. So I'm going to put 10 on top. And then I have x over 7 matches up with 10 over 5. See, the 7 and the 5, they match up. They are corresponding. So now I'll multiply by 7, multiply by 7. I'll just extend that out. X is by itself. Let's see, 5 goes into 10 twice. 2 times 7 is 14. And the units are millimeters. So this side is 14 millimeters. All right, number 4, here's our x. I'm going to put that on top. And it looks like I'm going to have 30 on the bottom, isn't it? Okay, which one matches up with x? Looks like the 12 does. So I'm going to put that on top. And the 30 matches up with the 18. So now I reduce. See, I'll multiply by 30. Right, so that gets rid of the 30. You have x by itself. Now I need to reduce. Well, let's see. We know that 6 goes into both 18 and 12. 6 goes in here 3 times. 6 goes into 12 twice. Hey, wait, 3 goes into 30. Right? 3 goes in there once. 3 goes into 30 10 times. So our answer is 2 times 10. That's 20. 20, the units are meters. So the length of this side is 20 meters. So again, notice how we're matching up the corresponding sides. Count number 5, we have a basketball pole. It's 10 feet tall, and it casts a shadow. In other words, what we do is we have a sunshine here, and it's casting a shadow. The shadow is 12 feet. And over here you have a girl that's 5 feet tall, and we want to know what her shadow is, x. Okay, so this is my x. So this is my triangle right there. Right, going up like this and over there. All right, so x over 5 is equal to, okay, which one matches up with x? 12 does. So that goes on top, just like I did the x on top. And to 10. X is to 5 as 12 is to 10. And then we simply reduce, I'm sorry. Let's see, I'll multiply by 5. Please show your steps if you want credit. And then, let's see, what do we have here? Well, 10 and 5. 5 goes into 10 twice. Oh, wait. 2 goes into 12. 6. So the answer is just 6 times 1, or 6. And the units are feet. So this 5-foot tall girl would cast a 6-foot shadow. Okay, use similar triangles to find the distance across the pond. Here's the pond. And how far distance is this right here? So we have two triangles. Notice the angles right here. See these right here, the ones with the one arc? Those two angles are the same. Of course, we know that. There's a name for that. And that name is vertical angles. Those are vertical angles. So those are the same. And this one right here with the 2 arcs, that matches up with this one with the 2 arcs. The one with the 3 arcs matches up the one with the 3 arcs. So that's what these tell you, what they correspond to. All right, so we have our side x. That's the distance across the pond. And let's see, what other number? So this triangle right here, what other side do we know of it? Well, we have 45. So this over 45 is equal to, now which one matches up with the 2 and the 3 arcs? 2 and the 3 arcs, that would be 8. So x matches up with 8. And we only have this other distance here, that would be 10. And notice, by the way, it goes from the 3 arc to the 1 arc, 3 arc to the 1 arc, so that's the same side. So I'll multiply by 45. Okay, that's gone. So what can we do? Well, we know that 5 goes in both 10 and 45. 5 goes into 10 twice. 5 goes into 45 9 times. Oh, then I have 2 times, 2 goes into 8. 2 goes into 2 once. 2 goes into 8 4 times. So now I have 4 times 9. 36. And the units I have are meters. So it's 36 meters across that pond. And we did that just by using triangles. And this is how, before GPS, this is how surveyors would figure out distance. They would use 2 similar triangles. Okay, turn the paper over. I'll start you on the first one, then you complete the rest. Okay, now we want to find, first of all, we're trying to find x. Here's x right there. Notice what we have is a small triangle inside a larger triangle. So if we're looking at the smaller triangle, there's this side, and that matches up with the big triangle, this length right here. So that means that this would be 35. Okay, on the big triangle. This is a small triangle, this is a large triangle. That's a small, this is for the large, it matches up. Okay, then I have this length. I don't know this one for the small triangle, but I know this one is 18. Okay, now which one matches up? I have 25 and I have 45. Which one matches up with 18? Notice the angles. This has a 1 arc, this has 2 arcs. This has 1 arc, this has 2 arcs. So it must be the 45. They must match up. Okay, so this was just extra, this number right here. You didn't even need it. So now we'll use this to solve for x. So I'll go ahead and I'll multiply by 18, both sides. I'll just extend that out. That's gone. And let's see, what can I do here? Well, I know that 45 and 35, 5 goes into both of those. 5 goes into 45 9 times. 5 goes into 35 7 times. Hey, now I have 9 and 18. 9 goes into both of those. 9 goes into 18 once. 9 goes into 18 twice. So my answer is just 7 times 2. It's 14. And what are my units? Millimeters. Okay, so we just found a corresponding sides to match up. And then we solve for x in 14 millimeters. Okay, you complete the rest of the problems. Again, you may want to go ahead and put x on the upper left position and solve from there. Make sure you show all your steps.